We're going to talk a little bit about design today, and you know, that's really going to be the part that finishes off this segment of, you know, of the course. Talking about beams and whatnot is learning how, you know, to design a little bit. Now, design when we're in the classroom, you know, it's not exactly like design out in the real world, because we're you know, we in the classroom try to limit our design to one variable. But there's many variables out in the real world, okay? But because we're just learning and we're getting used to all this stuff, you know, most of our designs are sort of limited so that you can focus in on one thing and you know, achieve that goal. Out in the real world, there's a lot of things. When we talk about reinforced concrete beams, I mean, what are the variables that are involved or potentially involved? Well, we got the width of the beam, you know, that's a variable. What else? Height would be one. How about we say effective depth? I mean, height definitely is a variable, but you know, that's tied into effective depth. Along with height, if you're going to mention that, you might think about cover, you know, what your stirrups are going to look like, so on and so forth. I mean, right now we're sort of at the beginning of the tunnel, so we'll put that out of our mind right now, but definitely those things too. So width, depth, what else? Area of steel. What else? How about steel yield strength? You know? How about concrete's compression strength? In addition to the other stuff we mentioned, like, you know, how much cover you're going to have, so on and so forth. You know, are you using stirrups? You know, are there many other things that we can get into? But for right now, I mean, just based on what we've done so far, you'd say, well, we've had problems and we've done examples and whatnot that have used these things. They could all be variables. They could all be involved. You could change them. You could change, and by changing them, you could change your design. We'll start out and we'll try to lock down certain of these variables so that we only solve for one of them. Okay? And then we'll broaden that out a little bit, but you know, for the most part, you're going to head into every problem, and your Fy and F prime C are going to be locked down. Okay? So really, most problems will take a look at one, or at least we'll start out taking a look at one of these, and the other couple will be locked down to make it sort of easy for us at the beginning. Yeah, we'll expand that a little bit as we go on, but you know, we'll start out sort of small and get a little bit larger, but still at that it's not exactly like designing in the real world. But anyway, so we got a lot of variables that we can take a look at. As a minimum in design, this is what has to happen. As a minimum, we have to have our design capacity, moment capacity, Phi(Mn), be at least equal to M sub U. It can be greater than or equal to, but it's got to be at least equal to. You got to know this going into design. You can't have a problem where this is not given or you are not able to find this. See, that's the other difference between classroom and the real world. In the real world, you're going to have to go get this. You won't be given a problem. You won't have a client come to you and say, hey, could you design this, you know, reinforced concrete frame building for me? And here's the, you know, the moments that you got to design for. Clients generally don't do that. You have to go out, you got to figure out what the loads are, what the building codes say this, that, and the other thing are. You got to factor the loads, you got to do your analysis, you got to get this. All right? So that is what at least has to happen. Okay? If we lock down stuff like compression strength of concrete and Fy, we could take the T times the quantity of D minus A over 2, and we could write this we can write that formula so it looks like this. That looks pretty cool, don't it? All right. Well, remember last week we talked about reinforcement ratio, and this idea that reinforcement ratio is really a better way of you know, I listed those variables up there before, area steel, B and D. Reinforcement ratio has all those things in it. Reinforcement ratio is the ratio of area steel to B times D. All right? And to talk about how much reinforcement is in a beam, it's more appropriate to talk about reinforcement ratio because that takes on, or that considers, the size of the beam. Okay? So this is actually a better equation. It's the same as this, but it's actually better. Okay, it's the same as, you know, phi times T minus D over D minus A over 2. Here's the thing on this. If I know what Fy is, and if I know what F prime C is, I mean, if I go into a problem saying I know Fy, I know F prime C, okay? I can go ahead, and if I know the various reinforcement ratios that I'm allowed to at least play with, because we talked about last week how there was minimums that I was allowed to use and maximums that I was allowed to use. There's a whole range that I'm allowed to, you know, be okay with. All right? I can't go over a maximum. I can't go under a minimum, but there's a range. So what I can do, if I know Fy, F prime C, or I've set those, and I've got a range of reinforcement ratios that the code says I'm allowed to use, what I can do is I can replace this and this just by a coefficient. Let's call that coefficient K bar. A lot of people call it K bar. Other people in other books call it other things, but a lot of people call it K bar. So what if I wrote the formula like that? That's starting to look better, isn't it? I mean, that looks pretty easy. The only problem with this is what? Yeah, what's K bar? How are you going to find K bar? What is this? Well, this is where no matter what book you have, no matter what resource you have, you know, they're going to give you a list of tables. All right? Tables might be in the appendix of a book. If you're using a book like the one I have in front of me, they list a series of tables that run from page 487 up through 495. Okay? So about 8-9 pages of tables. If you go to any other resource, any other book, you look in the back of the book, some books will actually list these tables right in the middle of the chapter or right in the middle of the lesson. Okay? But what all these tables have is they have, and you'll notice this, they have, first of all, they're set up, there's different tables, but they're set up, and at the top of every table they'll list what the table is being used for as far as Fy and F prime C. So again, they've locked down what those are. Then we'll have a value or a range of row values, reinforcement ratios. And they go from a low value all the way up to a high value. What's that low and high value? Well, the low value is the minimum reinforcement ratio that's allowed to be used, and the beam still be ductile. And the maximum that you're allowed to use, and for the beam to still be ductile, to still, behave so that it's tension controlled. All right? So in these tables, you'll notice you can look and it'll say row, and right next to it it'll have the K bar. So these have already been set up for you beforehand. So this ends up being a pretty straightforward type of an arrangement.